Hello, this video is about Nobel Prize in Chemistry in 1908, awarded to Ernest Rutherford for his investigations into the disintegration of the elements and the chemistry of radioactive substances. First, some illustrations. Here you see a nucleus emitting an alpha particle, which is 2 protons and 2 neutrons. So the nucleus of helium, that is. Here you see a nucleus emitting a beta minus particle, an electron. There's also a positive variant of that one called a positron. And here you see a nucleus emitting gamma radiation, which is in fact a brother of light with different frequency, of different energy, and different wavelengths. And all the particles have both a particle and a wave properties, which we will see in later Nobel Prizes. Well, the chemical nature of the alpha particles from radioactive substances is the title of the lecture, summarized by me. For the development of radioactivity, the study of alpha rays has been very important, since radioactive elements often expel alpha particles. Alpha particles were first observed in 1899. Becquerel showed the radiating power of uranium, observing Röntgen-like rays, X-rays, able of discharging electrified bodies. That is Rutherford, of course, investigated the rate of discharge, placing layers of aluminium on a layer of uranium oxide. Conclusion: 2 types of radiation with very penetrating power were present. One, labeled alpha radiation, is very readily absorbed. The other, beta radiation, is more penetrating. A still more penetrating radiation was discovered by Villard, now labeled gamma radiation. Giesel in 1899 showed that the beta radiation is easily deflected by a magnetic field in the same direction as cathode rays, thus having a negative charge. In 1900, Becquerel proved that beta particles are electrons and had a small mass, and can travel at speeds near to that of light. Kaufmann and also himself contributed, but Rutherford had to skip further developments. Most of the ionization done by rays is caused by the alpha particles. Most energy radiates in the form of alpha rays. Strutt and Crookes both suggested they might have positive charge. This was later proven. Alpha particles are less deflected by a magnetic field than beta particles and in the opposite direction. Alpha particles are also deflected by an electric field, and its electric charge divided by its mass ratio is 5,000. Well, hydrogen has one of 9,650. It was suggested that an alpha particle had twice the mass of the hydrogen atom, if the charge is the same, +1. De Coudre repeated the experiment with the same result, but the E divided by M ratio was only approximated. It was suspected that an alpha particle could be a hydrogen or a helium atom. I and Soddy investigated radioactive processes working towards the now accepted transformation theory. We concluded that radioactive bodies are in a state of transformation and the products were different from the parent elements, and that the transformation was not molecular but atomic. New bodies lost their radioactivity according to a definite law. The alpha particles are ejected from breaking up atoms. In some cases, also beta rays are emitted by atoms that break up. These large masses, alpha particles, ejected with a high velocity. It suggests that energy comes from rotational or oscillating energy from the parent atom, which must be large compared to an electron. What the forces are that expel the alpha particles we do not know. When radium expels an alpha particle, the residue atom is lighter, has become an atom of a new substance, the radium emanation. These are more unstable than radium and expel an alpha particle. This continues in a series of stages. Series of these transformations are now found for all known radioactive elements. Sometimes atoms break up without emitting alpha and or beta rays. Probably alpha particles are emitted. I think that must be gamma rays. But it can also be that the alpha particle is immense, but the speed is too low to be able to detect. Sorry. In 1903, Pierre Curie and Laborde showed that radium is self-heating, an effect that must be related with the ejection of particles by the radium. Some alpha particles that are produced are stopped inside the radium. Their kinetic energy is then converted into heat, due to which the temperature rises. Rutherford and Barnes showed in 1903 that this process actually exists. The daughter products also produces particles. The same happens there. The heating effect of radium is thus a secondary phenomenon. It is evident this takes place in all radioactive substances. The heat produced depends on the number and energy of the alpha particles produced. Rutherford and Surrey wrote in 1902 that stable substances that are formed in radioactive processes must exist in radioactive minerals. Often helium is found in such minerals. It suggests it may be an ultimate project of the disintegration of radioactive minerals. It is found nowhere else. It was time to invest if an alpha particle is identical to an helium atom. Using Giesel's radium bromide, Ramsay and Suddy in 1903 showed that helium was present in radium and that the emanation produced helium, stable in matter. Ramsay and Suddy are, by the way, both Nobel Prize winners. Was helium the end product or the product of a stage in the transformation of helium? Rutherford calculated that 1 gram of radium will produce 20 to 200 cubic meters helium per year. Dewar found 134 cubic millimeter per year experimentally. More accurately have since then come available. In 1905, Rutherford found that radium expels 6.2 times 10 to the power of 10 alpha particles per second per gram, and 4 times this number when radium was in equilibrium with its 3 alpha ray products. The rate of production of helium was calculated to be 240 cubic millimeters per year. Bragg and Clayman in 1904 showed that an alpha particle has great kinetic energy, travels in almost straight lines, ionizing molecules in its path. Alpha particles with the same speed all lose their ionizing at a certain distance when traveling through a substance, for instance air. I think that's ionizing power. Their passes through matter thus reduce their speeds by equal amounts. Rutherford confirmed these results, deflecting alpha particles in a magnetic field, and the particles were found all to have the same speed. And the speed of all particles were reduced to the same amount when they traveled the same distance through matter and can no longer be observed when the speed becomes 9,000 km per second or less. These homogeneous alpha rays can be used to determine the ratio E, the charge, divided by m, the mass, more accurately. The velocity of the expelled alpha rays from different matter differs, but the ratio E divided by m is constant, 5070. That is half of that of the hydrogen atom. We already saw that earlier, suggesting that the mass of an alpha particle is twice that of a hydrogen atom and equal to that of a hydrogen molecule. If the charge of an alpha particle was plus 2 and not plus 1, then its mass would be nearly equal to that of a helium atom. A decisive experiment proving that alpha particles is a helium did not exist. Proving that the plus 2 charge would help. Yeah, just proving that the charge is plus 2 would help. Rutherford and Geiger used a method to count for counting alpha particles being expelled. I have to skip the details about it. If you want to read it, go to the lecture itself. It was shown that 3.4 times 10 to the power of 10 alpha particles were expelled per second per gram of radium, and its ray products in equilibrium with it. Crookes, Elster, and Geitel used a different method, also details skipped, and came to several similar results. After that the total amount of charge of the alpha particles was measured, calculations showed that one alpha particle carried a positive charge of 9.3 times 10 to the power of man tiniest electrostatical units. The value for a hydrogen atom is 0.65 times 10 to the power of minus 10 for 1 plus charge. Thus an alpha particle has a plus 2 charge. You see, if you double this, you get that. An alpha particle with its charge neutralized is an helium atom. These data show us to magnitude the values of life, volumes of the emanation, the heating effect, all of radium, all agreed with the values found in experiments. Also, it was calculated by Rutherford and Geiger that 1 gram of radium in 1 year produces 158 cubic centimeters for helium. There were found in his experiments 158. Considering the difficulty of the matter, this is a crude agreement. There is no doubt that an alpha particle is indeed a helium atom. Incontrovertible evidence still had to be found, and it might be said that the appearance of a helium atom was the product of the disintegration of radium, but there was no connection with the alpha particle. It was necessary to show the connection between the alpha particle and the helium. Rutherford and Royce were able to have an emanation of radium emit alpha rays through a glass of a tube, but the emanation could not leave the tube. The alpha particles were caught, and after some days, the spectrum of the helium could be observed in the holding vessel. It was possible to shut out the possibility that the helium had diffused out of the tube into the vessel. Thus now it was clear the alpha particles turned into helium atoms. Also, when alpha particles are fired into lead or tin sheets, after a few hours helium can be obtained from the metal. Why are the alpha particles charged when they come out of the radium? This is probably due to the violent nature of the explosion of the radiatum and plunges through molecules of matter while traveling at high speed. It probably loses 2 electrons at the way. It is probable the case that radioactive elements are built containing helium atoms that are ejected during transformation. Probably 1 helium atom is ejected per radioactive atom during transformation. However, Bronson found that emanations of actinium and thorium expel 2 or 3. Using the expelled particles, one can calculate the atomic weight of the other products. Boltwood suggests that the end product of transformation series may always be lead. That helium is inert probably is why it plays this role in the radioactivity. Clear is that uranium, radium, etc. are no ordinary compounds of helium with an unknown element. It's not built up chemically. Apart from radioactivity, uranium, thorium, and radium show no special distinctive chemical behavior. Okay, that was the lecture summarized by me. Of course, some of the arguments were skipped because otherwise it would have been too long. But if you want to read those argumentations completely, then follow this link to the official Nobel Prize site, and there you can find the complete lecture. Here you see some other things that Rutherford did. This is supposed an atom. This is called the Plumbum model, and it was thought that the negative charges were concentrated and the positive charges were spread out, as you can see. And if you send positive particles to such an atom, they are not repelled by the positive charge because it's spread too thin, so it passes through. But what in reality happened is that sometimes the positive charge particles, the alpha particles that are sent to the atom, are bounced back due to repulsive forces. And that was a complete surprise at the moment. It's, compared to where you shoot with a gun at the wall and the bullet or the cannonball bounces back. It was completely unexpected, but it proved that the positive charge of an atom is concentrated in the nucleus. This is called the Rutherford medal. Yeah. Okay. This was it. Here you see, by the way, a transformation charge. You can follow if you have a parent atom and it sends out a neutron or a proton or an electron or a positron or an alpha particle, how the atomic weight and the atomic number changes. We'll come back to that in later Nobel Prizes. Okay, for now, thank you for watching. And next week we will go to the Nobel Prize in Chemistry for the year 1909.